My name is Georgia Stevens, and I'm going to talk about targeted therapy, the revolution in cancer treatment. But first, what exactly are cancer cells? Cancer cells are normal cells that acquire mutation in their genes. This mutation causes them to survive in conditions they shouldn't. Over time, they acquire more mutations, causing them to proliferate uncontrollably and form a tumour. So it's all about mutations in regular cell DNA. Mutations in the cancer cell DNA can lead to the production of abnormal proteins. Targeted treatment uses drugs that target specific genes or proteins only found in cancers. If a cancer has a specific protein or gene that is not found in normal cells, drugs can be designed to target these proteins and won't affect the normal cells. These proteins or genes are called cancer biomarkers. Targeted therapy is more specific than conventional therapy. For example, chemotherapy is not targeted and works on any rapidly dividing cell. This causes side effects such as hair loss. Targeted therapy is more specific to cancer cells, so has fewer side effects. To understand targeted therapy, you have to understand that each tumour is different. This means they can each have different biomarkers. Think of each tumour as having a different thumbprint. This means that no two tumours are exactly the same. This means not every tumour is the same, even within the same type of cancer. For example, a cancer that originates from cells in the lungs is called a lung cancer. However, each lung cancer can have cells with different mutations that produce different proteins. This means two people with lung cancer might have tumours with different proteins, therefore different cancer biomarkers. So this means that not everyone will respond to the same targeted therapy. 20 to 30% of all breast cancers have cells expressing a protein called HER2. HER2 can be targeted with a therapy called Herceptin. Breast cancer patients that have tumours with the HER2 protein are treated using the targeted therapy Herceptin. Herceptin works by binding to HER2, which allows it to kill the breast cancer cell. It will only bind to cells with HER2 on their surface. This means the treatment only works in patients with breast cancer cells expressing HER2.